Content-based image retrieval. I'll be talking about the types of image retrieval, what content-based image retrieval is, and the components and problems with it. So my capstone project is the Flutter AV Capture project, in which we are building an index catalog application using Flutter, and this allows a user to keep track of an inventory of items that are being stored, and the items contain a representation of an image along with its metadata and is stored based on an internal organization logic. Since this project is related to the storage and retrieval of image data, the topic of image retrieval is directly related to the purpose of this project. According to IGI Global, image retrieval is defined as the process of browsing, searching, and retrieving images from a large database of digital images. There are two main types of image retrieval, text-based and content-based. Text-based is the more primitive method, more traditional, of retrieving images and involves manually adding metadata to an image such as a keyword, captions, or descriptions. The problem with this is that the search system is dependent on human-entered descriptions, which can be inaccurate and time-consuming. It is a more labor-intensive way to retrieve images. Content-based image retrieval is the process of applying computer vision to the image search. Through content-based image retrieval, instead of analyzing text and metadata, the image's colors, textures, and shapes and other aspects are taken into account. This method produces better indexing and, by looking at similarities of the contents of the pictures, more accurate results. Other types of image retrieval include query-based, sketch-based, semantic-based, and annotation-based. Content-based image retrieval. CBIR uses image processing and feature construction. It extracts visual features and searches in that visual feature space for similar images. CBIR uses image distance measure and compares the similarity of two images based on color, shape, and texture. It takes the color distribution, mean, and standard deviation into consideration. Color is one of the most widely used features in image retrieval since it does not involve size or orientation. It describes how pixel patches of identical color are distributed in an image. The most common way to analyze color is through color histograms, which identify the proportion of pixels within an image that hold specific values. Color correlograms are enhancements to histograms by providing more info on the spatial distribution of colors. Segmentation partitions the image into many segments or sets of pixels and simplifies the image so that it is easier to analyze and understand. After segmentation is done, objects and boundaries can be located within images. Edge detection uses mathematics to identify points in an image where the brightness changes sharply. Shape filters help to identify given shapes of an image. Texture is used for identifying different regions of an image by looking at visual patterns and how they are spatially defined. These patterns are represented by texels, which are placed in a number of sets that define the texture and its location in the image. The gray level co-occurrence matrix models the texture as a two-dimensional gray level variation that describes the degree of contrast, regularity, coarseness, and directionality using the relative brightness of pixels. The problems with CBIR are the gaps in between the image processing and the understanding. There is a semantic gap between low-level content that gets processed and the high-level content of the image. There is the problem of how to mathematically describe a complex image and then how to analyze the similarities between images based on abstracted descriptions. Overall, CBIR can be useful across many fields and continues to advance. Thank you.